Well, I'm back out foraging for drinking water, and the reason I've got my shemag on is to protect myself from the mosquitoes. They're very irritating around here. So there was no dew this morning, so my second option and only other option is this stagnant pool of water. The problem with this is not only is there going to be the nasty parasites in it, but when it rains heavily and it does flow, it flows down from an old military dumping site. Not only that, but it also flows past a live firing range. So there won't just be the animal parasites in here, but there'll also be chemicals. So when I get back to base camp, we're going to have to take care of both of those. It doesn't look too bad, but you don't know really what's in there. Okay, we'll get that back and we'll get it processed. So we've got our biologically and chemically contaminated bog water, and the first process is going to be the same as the first process in the previous exercise, which is just to run it through a sphagnum moss filter, just to get out any of the bigger debris, clean it up a little bit. So I'm going to decant it from here through the filter, put it in our other dirty water bottle, and then I'm going to have to cut a filter from another plastic bottle to get it from there into here. I might be able to pour it actually. So we'll make a start. This is a slow process. And once we've done that, we're going to have to make a little fire, not just to boil it, but to actually evaporate it. So what we'll do is we'll build a small fire in here, put the contaminated water into a container. Ideally I'd have a metal container, but I don't have a suitable metal container. So I'm going to have to bring this up to heat very slowly. I found myself a piece of aluminium tubing and I've hammered the end down to fit into the top of the bottle. So that'll go in there somewhere. So it's coming out of there fairly clean. Pour it into here. Now if the situation was desperate, I would just boil that and drink it after it's gone through a rolling boil and then cooled down. But because of the possibility of chemical contaminants, then we're going to go a stage further. This will now get, well, I could have actually transferred it straight into our boiling vessel, but I'm going to go and get a few bits of kindling first and then get the fire started. So we just now want to build up a slow fire, move it towards the bottle, let the bottle heat up gradually. It'll boil the pond water in there, or the swamp water, which will evaporate. It'll travel down the tube and hopefully condense and drip into our collection bottle. There. I've got some oak, so that'll burn long and slow. So as we move it, because this will be quite a long process to get that bottle warmed up, we'll slowly shove the fire back. But once we've set it going, we can just leave it for long periods of time. Now your problem is resupplying the main bottle, because if you pour just cold water in it, you're very likely to, well, if you add it slowly you should be okay. You don't want to crack this bottle. I didn't mess about starting the fire, I just used a match, and I've progressed from those little vaping oil sachets of what I used to put lamp oil in, to a slightly larger bottle. You don't need a lot at a time, so this will last a long time. And I've got other methods in this tin. But this is not about fire starting, this is about making your drinking water safe. Right, so this is the setup. Hopefully you can see that we have managed to reach a rolling boil without smashing the glass. And the steam is travelling along the tube and being directed towards the neck of the second glass. I've buried the second glass in earth and I've damped that earth down, and you can see, I don't know whether you can see or not, but there is water running down into the second bottle, but it's not at a very massive rate, so it's going to take a long time to generate a reasonable amount of water, and it looks like there's a lot of losses in the system because there's a lot of water vapour escaping from the top of this bottle here. If that tube went down inside, came out down there somewhere, we might get more of the water condensed out. But it does prove the concept of the system. So the fire's going away nicely there. So there's been a considerable amount of effort setting this up. But once you've set it up, and as long as you can resupply the boiling vessel without smashing it, you probably want to do other things on the fire as well. But it is a way of distilling the water. So although I'm not reckoning I'm going to get vast quantities out of it, it can be left for reasonably long periods of time just to do its thing, and as long as you're supplying it with the swamp water, if you're going to be in one place for a reasonable amount of time, then I think it probably will be worth the effort. Everything you see here I've scavenged from the local area, and there were other things I could use, and now having set up the initial system I could improve on it, get better tubing, perhaps longer tubing so it has a long distance to condense, and it'll probably work a lot better at night when it's colder. But we'll leave it run for well, certainly until most of that water's boiled off, and we'll see how much we've collected. I reckon we'll lose more than half of it to evaporation, but we'll see. With the bits of oak I've got, the fire doesn't take much supplying. It's not a big fire, it's just enough to boil that bottle down. Anyway, the proof will be in the pudding, we'll see what comes out. Now, to resupply the main bottle that we're using to boil the water, to distill the water, I know we're going to have high losses in evaporation to the air. So I thought, how do I refill the bottle? If I pour cold water in it, perhaps I'll just smash the bottle. So I just put this second bottle here, which as you can see is now boiling. So I'm now putting boiling water into the main bottle. So I can lift that out and pour my boiling water in. And that's the boiling bottle fully recharged now. We haven't got a tight fit on the top. I think there's plenty of room for improvement on this. I think the basic theory works fine, but I think there is plenty of room for improvement before it is actually practical. So that is the finished product, which is actually a lot more water than I thought we would end up with, and that should be perfectly sterile. It tastes a bit funny, so it's obviously not, I don't know. But there's more water in there than I thought there would be. I couldn't see how efficiently it was working. I thought we needed a lot smaller tube. That was a tight fit in this bottle. So tight, in fact, I think when the aluminium has expanded, it's just cracked a bit of the edge of the glass. Oh, cracked it. Or maybe I just forced it in too hard. So there we go. That's only a viable option if you've got plenty of time, because it took a long time to get that water, and I had to refill this bottle up that was there with hot water. But it's worked surprisingly well. So that's the amount of water we got out of it. So fit that in there and we were losing a good 50% to evaporation, but I actually thought we would lose a lot more than that. So providing you can find the tube and the containers to boil the water, we've proven that you can use glass, but steel would be a lot better, steel or stainless steel. And as long as you've got plenty of water so you can cool your receiving bottle, which was this one, and I think it helped being able to cool this tube. So that's turning your biologically and chemically contaminated water into water that in theory you should be able to put in a battery and not do it any damage. Right, we'll pack this one up now.